All right, so the next lesson is on equations of sinusoidal functions. All right, so yeah, so last lesson we just looked at the graphs of these functions. Now what we're going to do is we're going to make the link between the equations and their graphs. All right, this lesson. All right, now the first thing to kind of point out here is the equations of sinusoidal functions. All right, are of these forms here. All right, the key thing here, notice, is that there's sine. Okay, so sinusoidal functions, yeah, so there are sine and cosine graphs if you were to use those functions. Now, sine and cosine, what ends up happening is the graphs themselves are very similar to each other, where they have this kind of wavy graph to it. The other letters in these I guess formulas here, the A, B, C, and D. These are what we call parameters. All right, and basically what will happen is there's numbers that will be plugged in for A, B, C, and D that affect the graph. Right, and we'll be able to actually find, just by looking at the equation itself and without actually having to graph it, we can figure out certain things like the amplitude, the period, the equation of the midline, and so on. All right. So yeah, so you can see here in this example, we have numbers substituted in for A, B, C, and D. Right. Cool, so let's just get right into it. So the following is the graph of y equals 5 sine 2 bracket x minus 4 minus 1. Okay, so this is the graph of this function. And what we want to do here is we want to find the amplitude, range, equation of the midline, and period. Okay, so what we're going to do first here is perhaps actually some review from the previous lesson, right? Because we're already given the graph. So once we find these different characteristics, what we're going to do is we're just going to make the link between these characteristics and the equation. So we will be able to find these things just by looking at the equation and not having to graph it, if that makes sense. Right? So the first thing I want to find here is the amplitude. And you can remember from the last lesson, the amplitude is the distance from the center to the maximum, which is equal to the distance from the center to the minimum. All right, so to find the amplitude, basically what we want to do here is we want to take the maximum, subtract the minimum, and then divide by 2. All right. So in this case, our maximum value here you can see is 4. So I'm going to go 4 minus. The minimum value here is -6. Right, so 4 minus -6. And then we're just going to divide that by 2. Right, so if you work this out, 4 minus -6 is the same as 4 plus 6, which is 10. 10 divided by 2 is 5. All right, so the amplitude for this function is equal to 5. Right. Next up, the range. The range we can get just by looking at the graph itself, right? So the range here, you can see the minimum value here again is -6. Our maximum value here is 4. So the range is going to be between -6, x, or sorry, not x, y. We're talking about the range. So -6 is less than or equal to y, which is less than or equal to +4. Okay, so that's the range. The midline, or the equation of the midline. So again, to get that, it's going to equal y equal. It's going to be y equals. And then this time what we do is we take the maximum, but we add the minimum and divide by 2. Okay, so if we were to sub in the values again, the maximum value is 4. To that, I'm going to add -6 and divide it by 2. All right, so 4 minus 6 is -2 over 2, which is -1. All right, so our midline here in this case is y equals -1. Now, yeah, so visually, if I went to here -1, if I draw kind of a dotted line across both ways, you can kind of see that eyeball-wise, you can see that it is the center of this, or the midline of this this sinusoidal function. All right, and again, you can see the distance from -1 to -6 is 5, right? And the distance from -1 to +4 is also 5. So that's your amplitude. Now, the last one here is the period. Okay, so the period, might not be too obvious. So basically what I'm going to do here is kind of guesstimate. All right, so the period here. So what I want to do here is I'm going to take into account, let's say, this maximum and this maximum, right? And I want to find the distance from between these two in terms of the x. All right, so yeah, so it looks like this x value here, if I draw a line down, again, this is just an estimation here, but it could be, I don't know, maybe 0.6-ish. And over here, if I draw a line straight down, it's not the straightest line, but perhaps that's what, 3.7-ish. All right. Again, I'm just kind of eyeballing it, but I'll show you the kind of like the algebraic way of actually getting the true period. But in this case, we're just kind of guesstimating here. So the period here, if I take the 3.7 minus the 0.6, we can say that this is close to 3.1 as the period. All right, cool. So we found, just from the graph here, we found the amplitude, the range, the midline, and the period. Now what I want to do here is actually take a look at the equation and see what we can see as like, not coincidences, but just numbers that line up. All right, so the first one here is the amplitude. We have an amplitude of 5. And you'll notice here that in front here is the number 5. All right, and it's not a coincidence that we call it A, and then here it's A, right? It's A, 5, 5, so amplitude is 5. All right, so basically what I'm saying here is that the first number, the number out in front is always the amplitude. Okay, so this is your amplitude. All right. Next up, the range. The range itself does not, how do I say, just immediately show up in the equation. What we actually want to do here is actually go to the third thing that we found, which was the midline. So midline, y equals -1. Notice here that we have a -1. Okay? So this is actually going to be your midline. All right, so whatever number follows at the end, so in other words, the variable or the parameter d, right, in this general form here, this is your midline. All right. So yeah, so if I know the midline, if I know the amplitude, then I can actually find the range, right? Because the range itself, I hope I have room here, is if I take the maximum, or to find the maximum value, if I take the midline, which is d, and add the amplitude, I should get the maximum, right? So in this case, my midline here was -1, but if I add 5, I get +4, and you'll notice that that is the maximum value of this function, right? So again, visually, right, if I know where the middle is, and then if I add the amplitude, right, so if I know what d is, if I add a, which is the amplitude, it should take me to the maximum value. Right? And similarly, if I take the minimum, to find the minimum, I can start at the center here, which is this number back here, and this time I could subtract a. So if I take -1 and subtract 5, that should give me the minimum, which in this case is -6. All right, so we can find the range as long as we know the midline and the amplitude. All right, so again, it's the midline plus the amplitude, and midline minus the amplitude will give us our maximum and minimum values. All right, the third one here is, or sorry, the last one is to find the period. The period itself, all right, again, does not just show up here. But what I'm going to tell you is that this number that's in front of the brackets, this affects your period. So I don't want to write period. I'm just going to leave that there. Just make note that this number here is 2. All right. So basically, your period, when it comes to the equation, is going to equal it's always going to equal, right, 2 pi. So 2 pi is like just the standard number. It's always going to show up, divided by the variable in front, which is b. The number in front of the brackets, which is b. All right. So in terms of parameters, again, it's this number here. So whatever this number here is, you take 2 pi, always take 2 pi, and divide it by this number. So in this case, it's going to be 2 pi divided by 2. So just scroll this down here a bit. All right, so this is going to be 2 pi divided by 2, which is equal to just pi. Right? Now, this as a number itself is 3.14 ... So you can see that it's close to 3.1 when we round it. That's kind of like what we found here as the period. Right? So it took 3.7 minus 3.6, just kind of eyeballed it, subtracted it. We saw visually that the period is around 3.1, and as it turns out, it's actually 3.14, the value of pi. So that's the period in this case. All right, so I always take 2 pi and divide it by b. All right, cool. So yeah, so from the equation itself, we can find these 4 things as well. Now you might be wondering, what about the -4 here, which I'll use a highlighter here. What about this thing here? It does affect the graph, but for the context of this course, we don't really need to focus on it at all. Right? So that last parameter, the C parameter, it actually shows up and gets focused on in the pre-calc 12 course, but not in the foundations of math 12. So you can just basically ignore that number. Right? So this number, it does affect the graph, but it's not part of the course content of this course. All right, cool. All right, so let's jump to this one here. Next example. Again, determine the equation of the midline, amplitude, range, period of this function. All right, and then what we're going to do is we're going to confirm it with graphing technology. So once we find these things here, I'm going to punch this into Desmos, and we'll just confirm what we found is true or right. All right, so first one here, midline. Let's do that. So midline. So this is going to be y equals, and remember it's this last number here. So in this case, it's going to be y equals -2. All right, so that's the equation of the midline. Next up, what do we want here? The amplitude. So amplitude. Amplitude. So A is going to equal. All right, so now what we want to do here is we want to look at the amplitude is always the first number here. Now with amplitude, it's the distance from the center to the maximum, center to the minimum. So if you get a negative value out here, your amplitude, this is one of the key things here, is your amplitude is always just the positive. We're talking about distance, right? So we're talking about the distance from the center to the maximum or center to the minimum. So in terms of like how far it is from the center to the maximum, it's going to be positive 4 units, right? So if you get a negative number out in front here, you just take the positive, right? If it's a positive number, it just stays positive. So the amplitude in this case is 4. All right, so therefore we have the midline, we have the amplitude, so we can find the range now. All right, so the range is between, all right, so our minimum value is the midline minus the amplitude. So in this case, the midline was -2, my amplitude is 4. So the minimum value here is going to be -6. Right? And likewise, my maximum, I'm going to take the midline, but this time I'm going to add the amplitude. I'm going to take -2 and add 4, and we get +2. All right, so if we take this into account, our range, therefore, is between -6, so -6 is less than or equal to y, less than or equal to +2. Okay, so this would be our range. All right, and the last thing we want to find is the period here. All right, so the period is equal to, it's always 2 pi, and then you're going to divide it by b, which is the number in front of the brackets. All right, so in this case, 2 pi over 3. Now I can leave it like this, or what I can also do is change this to a decimal. So this, or a number, yeah, fraction. It's a fraction now, but a decimal. Right? So I'm just going to punch that in. 2 times pi divided by. All right, so 2.09. So let's call it 2.1. Okay, so the period should be 2.1 units. All right, cool. So now what I'm going to do here is, take this function here and plug it into Desmos and just confirm these values off the graph. All right, so let's just do that. I'm just going to copy and paste this. All right, this works. Nope, I got an error. Oh, I'm going to need brackets for this. Oh, all right, so there it is. So this is the graph of the function that we just looked at. Let's just throw in some grid lines here. Minor ones. All right, so let's take a look here. I'm just going to toggle back and forth. All right, so the first one here is the midline we found. All right, so y equals -2. So if I go back to here to the graph, -2 is here. And you know what? Actually, I'm just going to punch in y equals -2 and let it draw it. And you can see that, yes, this appears to be, or it is, the middle between the maximum. So at -2, we got a distance of 4. At -2 to +2, that's a distance of 4. So this is the midline, yes. Cool. Next up, let's take a look at the amplitude. So we've got an amplitude of 4. And again, distance from the midline to the maximum here, you can count here is 4 units. Or in other words, 2 minus -2 is 4. So you can see that there's 4 units there. So that's confirmed. The range is between -6 and 2. All right, so you can see in this graph, you have the low point here is -6, and the high point here is +2. Right, so the range is between -6 and +2. And now the period. All right, so we say the period is 2.1. So looking at this graph, perhaps, let's take a look here. So this maximum here is pretty close to 0, it's just slightly more. And then if I go over 2 units in a bit, you can see that, this is the next maximum. All right, so it does appear that the maximum here is, the period here is 2.1. So, so all of those values there are confirmed. All right, so again, this is just using the equation. You should be able to now pick out these different characteristics. All right, cool. I think I got one more example. So this is kind of like an application question, but we're just going to use what we just learned and answer these questions. All right, just without actually having to graph it. All right, so let's take a look here. So here we have the height of a chair on the high roller Ferris wheel is described by the function. Okay, so we're given the function. So this is the height of a chair as it goes around in a Ferris wheel. You guys know what a Ferris wheel is, hopefully. Actually, you know what? The high roller Ferris wheel is in Vegas. They just actually I'll go back to Desmos. So anyways, so I think it's the largest Ferris wheel in North America. So anyways, this was built a few years ago. So this is a Ferris wheel. So basically what happens is you get on at the bottom and you go around, you take a look at the whole city, and then you're back. All right, so this is a ride, in Vegas. So this is the function that models the height of a chair given its time. All right, so the height is in feet, and T represents the time in minutes. Right, so the height of the chair given the time. All right, so what are the maximum and minimum heights you can reach if you are riding the Ferris wheel? All right, so this Ferris wheel. So looking here, we can see that the amplitude, we can just read it off the equation. Right? The amplitude is 260. Right? This number here, 260 feet. And we can also see that the midline is equal to 290 feet. All right, so therefore, given these two bits of information, you can see that the maximum height is going to equal the midline, which is 290 feet, added to the amplitude, which is 260. So we can see that this is, I'm trying to do that in my head, 550 feet. Okay, so that is the maximum height. The minimum height is going to be the 290, but this time we're going to subtract 260, the amplitude. And so the minimum height is actually 30 feet. Okay, so the bottom of the wheel is still 30 feet above the ground. All right. Cool. So next up, determine the diameter of the Ferris wheel. So the diameter of the Ferris wheel, if I was to kind of just do a quick sketch of the Ferris wheel. So basically, yeah, so we got this Ferris wheel. You get on at the bottom. The bottom is still 30 feet above the ground. Right? This is 30 feet. Up here was, what was it, 550, I think it was. Yeah, 550. All right, so therefore it makes sense that the diameter, which is the distance from the maximum to the minimum, so this distance here, this is your diameter. Okay, so distance here. So the diameter itself is pretty simple. We're just going to take the maximum height, 550 feet, subtract the minimum height, which is 30 feet, and you can see that this is 520 feet. All right, so the diameter of the this Ferris wheel, the high roller, is 520 feet. All right. And it's also equal to, you can think about the amplitude here, which is the distance from the center. So the distance from the center, the distance from the center to the maximum or the center to the minimum is your amplitude. So this is also, think about it, right? If I take the 260, which is my amplitude, and multiply it by 2, that gives me 520 feet, which is the diameter. Cool. And how long is the ride? All right. So when it's asking how long is the ride, basically how long does it take to get on board, go all the way around, and back off again? So how long in terms of time is the ride? So so we can see here, if I scroll back here in the equation, b is equal to pi over 15. All right. So that's the number in front of the t here. So if b is equal to, let's write that down. B is equal to pi over 15, then we know that the period itself is 2 pi over b. All right, so in this case, it's going to be 2 pi over, and I'm just going to sub this in, so pi over 15. Now, since we're dividing by a fraction, this is the same as multiplying by its reciprocal. All right, so instead of dividing by pi over 15, I'm just going to write this as 2 pi times 15 over pi. Now, if I multiply this together, you can see that the pi's actually cancel out. All right, so therefore, 2 times 15 is equal to 30. All right, so, and the time was in terms of, it says t represents the time in minutes. Okay, so one period here or one rotation takes 30 minutes. So that is how long the ride is. All right, cool. And you know what? Let's just plug this into Desmos fairly quickly and just confirm the answers that we found here. All right, so I'm just going to take this function. So let's plug that into Desmos. And we'll just confirm the values that we got. Now, oops. All right, so you'll notice that there's no error message. We're zoomed in too far, right? So have to. All right, so you can see that the function is way up here. Okay, so with Desmos here, I'm just going to show you some of this stuff here. We can actually adjust, our x-axis and y-axis. So for the x-axis, remember that it took 30 minutes. So yeah, so I don't really need -150 to +170. I could just fidget this to, actually we'll start at time 0. And each rotation takes, how long was it? It was 30 minutes. So let's just put in, we'll go 100. All right, so we've got 3 rotations. And similarly from the y-axis, we know the minimum was, what, 30 feet. So perhaps I'll put in 25 as my minimum. And the maximum height was it 550? So let's just go up to 600. All right, so what this does, it just kind of changes the view or the window settings here. So again, I do these values here because we worked out the question and just want to make sure that it fits into the screen. Cool. All right, so let's take a look here. Yeah, so you can see the there we go. The maximum height here, I just clicked on it, is the Y value here is 550 feet. Our minimum value here is at 30 feet, my Y values. And then how long did it take for the ride? So I guess technically we would just let that over. You get on at time 0, right? We go all the way up to the maximum height, come all the way back down. So at 30 minutes later, we get back to the bottom. Right? So this graph here kind of confirms what we found in answering these questions. Right? So again, the maximum height was 550, the minimum height was 30. So those are our Y values. Right, and you can see here that the Y value here is 30. The maximum Y value here is at 550. Right? So maximum height 550, minimum height 30 feet. What else we got here? Diameter. All right, so it's 520 feet. Yeah, so you can see that distance from here to here, from maximum to minimum, is 550 minus 30, which is 520. What we got here. And how long is the ride? So the period is 30 minutes. And again, here we get it on at time 0, goes all the way up, comes back down at time 30 minutes. Right? So that's one rotation. Cool. So hopefully that makes sense, guys. Make sure I caught touched on everything. Yeah. So this lesson here a little bit longer than the other ones, but yeah, hopefully you got a good handle on it. It's just picking out these different characteristics based on just the equation. So, all right. Cool. Ciao.